This video is going to talk about chemical reactions. We're going to go over what a chemical reaction is, the different parts of it, how to read them, and then we're going to start to talk about how to balance them. So by the time you're done with this video, you should be able to balance chemical reactions. So up first, what is a chemical reaction? So a chemical reaction you've actually learned about before. You've previously learned about physical and chemical changes, and a chemical change is a chemical reaction. So it's a process in which atoms of one or more substances are rearranged in order for new substances to be formed. So this key is new substances. We're looking for something new. So for example, as we go over this, the chemical reaction cellular respiration is taking place in your body. Cellular respiration is when we take glucose and oxygen and we convert it into carbon dioxide and water. So we start with certain substances and we end with other substances. You'll notice it all has carbon, hydrogen, and oxygen, but the way that it's arranged is different. So let's talk about the different pieces of chemical reactions, and let's talk about how to read them. So up first, we need to talk about the reactants versus the products. So the reactants are the substances usually to the left of the arrow. So up here, these would be our reactants, glucose and oxygen. And then our products would be to the right of the arrow. Our products in this case would be carbon dioxide and water. So reactants you start with, products you end with. Next, you guys already know this one, but the little tiny numbers right here, these are called subscripts. And you remember this because of writing chemical formulas, which you absolutely adore, but subscripts are those teeny tiny little numbers next to it. So let's say, for example, we had H2O. So if we had H2O, the subscript 2 next to H would tell us that there are two H's, two hydrogens. And then O, even though there's not a subscript next to it, we assume that there's just one and we don't write it. Like I said, that's all review. So take a second, pause the video, and fill this out. Where is H and where is O? Okay, you should have had our two H's down here and O right here, because our subscripts tell us how many are within that molecule. A number that goes out front of a chemical formula is called a coefficient. So a coefficient is the number written in front of each reactant or product. So up here, we don't have a coefficient here, so it means it's just 1. Our coefficient of O2 is 6, CO2 coefficient 6, and this one would be as well. So the coefficient is out front, and that tells us how many molecules we have. So once again, if this number is 1, then it usually does not get written. So then it is usually not written. So coefficients tell us how many of each compound there are in reaction. For example, that equation we just looked at, there's a number 6 in front of O2, which means there are 6 molecules of O2. So we're going to practice this by drawing 6 O2 molecules. That way we can differentiate what this means. So one O2 molecule, we know it has a double bond, and it looks like that. So this would be one of our O2 molecules. So if we had the coefficient of 6 O2, that means we would have to have 6 of these, because right now we only have 1. So pause the video and practice drawing 6 of these. Okay, so yours should look like this. We have 6 O2 molecules, 1, 2, 3, 4, 5, 6, and that's where we get this coefficient of 6 from. All right, so now that you know the different terms, let's take a second and just practice. Let's check in and make sure you know what you're doing. So I want you to place a box around the products and circle the reactants. Then place a triangle around the subscripts and underline the coefficients. So pause the video and give that a try. Okay, it should look like this. So if you put a box around the products, you had a box to the right side of the arrow. And then if you were to circle the reactants, you circled the left side. A triangle around the subscripts, you should have had this. And if you put a triangle here and here, that's fine as well. Just make sure you know that those are both 1. And then underlining the coefficients looked like this. And if you underlined this and wrote a 1, that would be fine as well. All right, so now you know the vocab. Let's move on. There's some symbols you're going to see in chemical reactions that you need to know. First of all, a plus sign. Of course, you know what a plus sign means, but it's really there to help separate the substances in a chemical reaction and not just show they go together, but we're also showing that we're separating the substances. And keep in mind, when we keep using this word substance, we're really referring to parts of matter. Remember, matter can be broken into 2 categories, pure substances and mixtures. And a pure substance would be an element or a compound. Up next, if you see an arrow, you read that as yield. So you would always read that as yield. And this separates the reactants from products. Sometimes you'll see an arrow that's going both directions, and that just means that a chemical reaction is reversible. Or maybe it's existing in a state of equilibrium where it's going back and forth. S, L, G, and AQ. S, L, G, those are going to be states of matter. So we have solid, liquid, gas. So if you have an S written next to something, it is going to be a solid. L is liquid. And then G is gas. And most of the time, these are italicized as well next to those. AQ, you've probably not heard of this one. This indicates that a substance is in an aqueous solution. So an aqueous solution, think about aqueous aqua. It's just a water-based solution. So an aqueous solution means it's in water. Okay, so now you know all of the different parts to a chemical reaction and what it is. So since you now know all of these terms and the symbols, we're going to move on to talk about how to balance chemical reactions. So before we talk about balancing chemical reactions, take a second and pause the video and answer this question. So in your own words, what does balanced mean? So maybe for balanced, you wrote down that something would be equal, or maybe you put the same or something else. But when we think about something balanced, or if something is balancing, we're trying to get them to be equal. We're trying to get them to be the same. So just as we think of balancing in normal terms, it's going to be the same thing for a chemical reaction. If you're wondering, well, why are we balancing chemical reactions in general? Why do these things have to be balanced? It has to do with this thing called the law of conservation of mass. Sometimes it also might be called the law of conservation of matter. Those are the same thing. So this law basically says that matter cannot be created or destroyed. Matter just changes form. So matter or mass cannot be created or destroyed, it changes form. So when we're looking at a chemical reaction, and if we're looking at the reactants versus the products, we should have the same number of atoms on each side. If we have somehow gained atoms, it looks like we've created matter, which we cannot do. Or if we have somehow, lost atoms, it looks like we've destroyed matter. And even if you light something on fire, you have not destroyed the matter. It's just changed forms into something else. So we have to balance chemical reactions to fulfill the law of conservation of mass. Okay, so now we know what it means if something's balanced. We know why we have to balance. Time for us to start talking about how this actually works. So while we go over the steps of how to balance a chemical reaction, we're going to actually be working through one over here. So up first, the very first step to balancing a chemical equation is you have to make sure that you write down the equation, which check, the equation is written down here. Perfect. We just want to put that because sometimes you might see the equation as like a word problem, and you need to make sure you write out all the pieces and parts first. The second step is called the atom inventory. And this should sound familiar to you from your investigation because you learned how to do atom inventories in your investigation. So here's how the atom inventory works. Watch carefully. Wherever the arrow is, directly under the arrow, you're going to make a list of all of the atoms and types of atoms in the compound, so our elements. So right under this arrow, I'm going to list, I see iron and oxygen. So I will write down Fe and O. The reason we want that directly under the arrow is because it separates the reactants from the products. So when you're creating your atom inventory, it's very easy to see what you have starting with and what you are ending with. That way you don't have to create some sort of chart. It creates the chart for you by writing it in the center. Now we're going to start counting. So iron, here there's only one of them. Oxygen, there's 2. So we put a 1 and a 2. Now we're going to do the same for our products. Iron, there's 2. Oxygen, there's 3. And that's our atom inventory. The next thing that we have to do is we're going to start changing the coefficients. So by changing these coefficients, we can change how many atoms of everything we have. Now notice, you can change the coefficients. You cannot change subscripts. So you can change coefficients. You cannot change subscripts. That is a big no-no. You cannot do that. All right, when it comes to changing the coefficients, it's helpful to go in a particular order, and it goes metals, non-metals, and then save hydrogen and oxygen for last. When you're balancing things, keep in mind that you might have to erase and rewrite multiple times, and that is completely fine. That is to be expected. Sometimes you start balancing something and unbalances something else and you have to go back and fix it. That's fine. So here's how we change the coefficients. We start with our metal. So our metal would be iron. We have to balance this because we have a 1 here and a 2 here, and those aren't equal. We need them to be equal. So what we'll do is we're going to change the coefficient in front of Fe. Now, because we've multiplied that by 2 up there, we now have 2 iron, which makes it even. So as soon as we put this 2 up here, we've changed it to 2. And that's awesome. Those look balanced. Fantastic. We're going to keep changing the coefficients until they're even. So now we've got a 2 on this side and a 3 on this side, right? We've got 2 and 3. I can't multiply 2 by a whole number and turn it into 3, or vice versa. The only way I could do that would be to multiply it by a fraction, and we're not going to make fractions coefficients. So what we have to do is figure out a number they can both go to become equal. So I could take 2 and multiply it by 3 and get 6. And I could take 3, multiply it by 2 and get 6. So whatever we need to multiply it by, that ends up as our coefficient. So let's rewrite that. So if I multiply the O by 3, I'm on the reactant side. I'll cross that out and write down 6 because 3 times 2 is 6. Over here, if I put a 2 as our coefficient, well, 2 times 3 is 6. And now those are even. That's awesome. Except here's the thing. Whenever we put this 2 here, it also affects iron. It doesn't just affect oxygen, it also does iron. So now on this side, we have 4 irons. And you're probably thinking, but we just fixed the other iron. What do we do? So whenever this happens, we're going to go back to this coefficient and we're going to try again. So now if this is 1, we need it to be 4. We can multiply it by 4 and ta-da, it is equal to 4. So now everything is balanced. Our atoms and our inventory match because we've changed the coefficients in order to get them to match. So the last thing that we're going to do is just recheck for balance. We just want to recheck and make sure everything's good. So we have 4 irons, 4 iron, 6 oxygen, 6 oxygen. Everything is balanced and it's good to go. All right, so that was nice and slow for how this works. The second example, I'm going to do this one with you as well. And then example 3 and 4, you're going to start to try on your own. So here we go with example 2. So the very first step is write the equation. That's done. The next step is to create our atom inventory. So we're going to make a list. We have Na. This is an I for iodine. And then we have Cl. We have the same thing on the other side. NaClI. Now be careful because our order is different here, but that's okay. Finish up our atom inventory. We have 1 sodium, 1 iodine, 2 chlorine. Because we have 1, 1, 2. On this side, we have 1 sodium, 2 iodine, and 1 chlorine. So here's our atom inventory. The next thing we need to do is start changing the coefficients in order to make this balanced. So if we look across here, sodium is already balanced. That's fine. We don't have to change that coefficient. And then iodine and chlorine, though, they need some help because there's 1 on this side, 2 on this side, 2 and 1. And if we look at the order, it says metals, nonmetals, hydrogen, and oxygen. So from that, our metals already balanced, so we can pick either nonmetal to start with. Let's just start with iodine because it's first on our list. So iodine, we have 1 on our reactant side, and we need to fix that. So to take this 1 and turn it into a 2, I can multiply it by 2. If I put a 2 here, it changes iodine to 2. Awesome. It also changes sodium to 2. So we'll cross that out. Iodine is balanced, fantastic, except we unbalanced sodium, so let's fix that. So we unbalanced sodium. On this side, we have 1. We can change a 1 into a 2 by multiplying it by 2. So we put a 2 as our coefficient. That changes sodium, it's now 2, and it also changes chlorine. Chlorine is now 2 as well. If we look across sodium, we've got 2 and 2, it's balanced. Chlorine, it just so happened that balanced it for us. So our last step is we just need to recheck and make sure everything's balanced. 2Na, 2Na, 2I, 2I, 2Cl, 2Cl. Everything is balanced. In those blanks, if you would like to write a 1, you can, but it's not necessary. Okay, example 3. Let's start having you try some of this on your own. So why don't you try to do the atom inventory on your own? Maybe even try to start balancing it too, just depending on your comfort level. But go ahead and try the atom inventory. So where we make the list of what we have, try that part on your own. Okay, so you tried the atom inventory on your own, and it looks like this. We notice that Au, gold, is already balanced, and that's our metal. That's already good to go. But our chlorine is not balanced. We have 3 on one side and 2 on the other. So to fix that, we need to multiply them both by a number to be equal to something else, right? So chlorine is 3 on this side. If we take 3 and multiply it by 2, we now have 6. And if we have 2 on this side, we can multiply it by 3 to get 6. Those look even. That's awesome. Here's the thing. When we multiplied this one by 2, while it went to chlorine, it also went to gold. So now gold is 2. To fix that, we notice on the other side, we just have 1. So if we put a 2 here, that balances it to 2. Okay, and let's just recheck, make sure that's balanced. 2Au, 2Au, 2 times 3 is 6, 3 times 2 is 6. It is perfectly balanced. Okay, example number 4. Try this entire thing on your own. So pause the video, make the atom inventory, change the coefficients, and check. And then if there's a particular place that you're getting stuck at, make sure you ask for help. Okay, pause the video, give this one a try. All right, let's go over example number 4. So we have atom inventory, phosphorus and oxygen. We've got 4 and 2, 4, 2, and we have 2 and 3, 2, 3. Okay, so for balancing, we go metals, no metals, non-metals. We start with phosphorus. We have 2 over here, and we can change a 2 into a 4 by multiplying it by 2. 2 times 2 gives us 4, and 2 times 3 gives us 6. For oxygen, we have 2 on this side. We can change a 2 into a 6 by multiplying it by 3. 3 times 2, now we have 6. And that balances it. But let's double check. 4 phosphorus, 6 oxygen, 6 oxygen. It is balanced. Okay, so now that you are getting more comfortable with balancing, we're gonna step it up a notch and we're gonna try some more difficult problems. So I wanted to make sure that you had some strategies for how to deal with more difficult problems, like ones that have polyatomic ions in them. All right, so in-person learners, I sent your copies to the copier before I realized, hey, there's a typo. So one of these days, guys, I'm gonna have copies that don't have a typo in them. Distance learners, I already fixed your copy online before I posted it. So in-person learners, this first example, example 5, cross out that ending. I don't know what happened when I was writing that. I think I was trying to copy down this line up there or something. So anyways, example 5 should read like this. You should have AlOH3 plus H2SO4 yields Al2SO43 plus H2O. So I'm so sorry about that, guys. Thank you for bearing with me. Alrighty, let's talk some strategies for this. So whenever you have polyatomic ions, you need to check if they stay together. So OH is a polyatomic ion, but it does not stay together. SO4 is a polyatomic ion and it stays together. So because of that, if you have a polyatomic ion that stays together, when you write out your atom inventory list, you keep it together. So here's what I mean. We have Al, OH splits apart, so we're going to put O and H separate. And then we have SO4. So we're putting the entire polyatomic ion there. And then let's count these out. On our reactant side, we have 1 aluminum. We have 3 oxygen because we're going to count this oxygen as part of sulfate. Hydrogen, we have 3 and 2 makes 5. And then we only have 1 sulfate group like that. Let's count the other side. We have 2 aluminum. We only have 1 oxygen. Hydrogens, we have 2 hydrogens. And then SO4, we have 3 of them. So let's talk about then how to balance. So in our order, on our steps of how to balance, we start with metals. Aluminum is a metal, so we'll start there. We have 1 here and 2 here. I can change a 1 into a 2 by multiplying it by 2. So now this becomes 2. But that also changes our oxygen and our hydrogen. So oxygen now changes to 3 times 2 is 6. And then hydrogen on this side, we have 3 times 2, well that's 6, plus we have another 2 from here, so we have 8 on this side. It's a little bit more complex. All right, let's keep going. So we did all of that just to change aluminum. Fantastic, aluminum is now balanced. Let's look at what to do next. Our list says metals, nonmetals, oxygen, and hydrogen. Hydrogen's very last. So that would mean sulfate needs to be balanced next. So there's 1 here, 3 here. We can change a 1 into a 3 by multiplying it by 3. So that goes to sulfate, now has 3. And we get to re-add all of our hydrogens together. So here goes. On this portion, hydrogen, we have 2 times 3 is 6. And now we have 6 from over here. So we have a total of 12 hydrogens on this side now. So we have balanced aluminum. We've balanced sulfate. Next, let's balance oxygen. We have 1 here, and now we have 6 over here. We can balance that. Multiply it by 6. Now we have 6. And of course, when we move the 6 here to change oxygen, it also changes hydrogen. And now it becomes 12. But hey, that worked out in our favor. Oxygen and hydrogen got balanced in one big swoop. Okay, let's double check and make sure everything is balanced before we wrap this up. 2 aluminum, 2 aluminum. Oxygen, we have 2 times 3 is 6 over here. Oxygen over here is 6, so that's good. Let's double check our hydrogen. 2 times 3 is 6 plus 6, so we have 12 on this side, and then we've got 12 over here for hydrogen. That hydrogen was part of the other hydrogen we already checked, so we check sulfate. We've got 3 and 3. It's perfect. So our equation is balanced, and the ratio of our coefficients goes 2, 3, 1, 6. All right, so for our next example, example 6, Remember that one time I said, hey, hopefully we don't find any more typos? Well, guys, there's another typo. So for your equation right here, it should just be CaSO4, and yours has an extra 2 on it. So erase that or scribble it out or rewrite it. But anyways, let's work on this one. Okay, but distance learners, by the way, it is fixed on your copy, but sorry, in person, it's not fixed on yours. Okay, so let's start with our atom inventory. So go ahead and pause the video and work on your atom inventory. All right, so your atom inventory should look like this. So when it comes to balancing, we'll start with aluminum because calcium, our other metal, is already balanced. Aluminum, we need to change our product 1 into a 2, so we'll multiply it by 2. Changes aluminum to 2, but it also changes hydroxide. That's now a 6. Aluminum's balanced. Up next, we can work on sulfate. It is a 1 on the product side and a 3 on the reactant side. So we will change our 1 into a 3 by multiplying it by 3. It also changes calcium though. Calcium is now a 3, but we wanted sulfate a 3, and that's perfect. So aluminum's balanced, sulfate's balanced, but we need to go back and fix calcium then. So on our left side, our reactant side, it's a 1. Let's multiply that by 3 and turn calcium into a 3. But it also changes hydroxide. However, it is really convenient because we multiply that 2 by 3, it becomes 6, and that balances the equation for us. Okay, hopefully there are no more typos in the next couple. Hopefully. All right, for 7, try this one completely on your own. Go ahead and pause the video, give it a try, and then whenever you're starting to feel stuck, play the video and find where you need help with. All right, so we're gonna go through this one pretty quick. Your atom inventory should look like this. So we'll start with our metals. So we're going to start with iron. We have 2 on the reactant side, 1 on the product. Let's fix our product. This 1, multiply it by 2 becomes 2. That also distributes to our hydroxide. Now hydroxide has 6. So iron is fixed. Our other metal to fix would be potassium, K. It is a 1 on your reactant side and a 2 on your product side. So we fix that by multiplying by a coefficient of 2. That changes potassium, and it also changes hydroxide. Okay, so that fixes potassium. Sulfate and OH are both unbalanced, so we can pick either to start with. We'll just go ahead and work with sulfate because it's first on our list. So sulfate on this side is a 1, this side is a 3. We can change our product to become a 3 by giving it a coefficient of 3. That changes sulfate to a 3, but it also changes potassium that we just balanced, and that's okay. Potassium now becomes a 6. So sulfate balanced, great. Potassium is not, so we need to go back and fix this side to become 6. So let's erase this and work on this one again. So to make this into 6, we're going to give it a coefficient of 6, because now 6 times 1 is 6. It also changes hydroxide though, and it is now 6. But that works out perfectly because now it's balanced. And we can go back and do a really quick check. 2 iron, 3 sulfate, 6 potassium, 6 OH, 6 OH. All right, try example 8 on your own. So example 8 is a little bit tricky. If you don't go in the proper order, you might feel like you're working yourself in the circle. So we need to watch our order. Metals, don't have any of those. Non-metals, hydrogen, and then oxygen. So you should balance in the order carbon, hydrogen, and oxygen. Carbon over here has 1, hydrogen 4, oxygen 2, and be careful on this side because our oxygens are split up, and it looks like this. So our carbon's already balanced. The next thing we need to balance is our hydrogen. We can take 2 and turn it into 4 by multiplying by 2. This now becomes 4, but it also changes our oxygen. We have 2 here and 2 here. That makes our total on this side 4. And now we can go back and change this 2 into a 4 by multiplying it by 2. So now this becomes 4, and we are balanced. Okay, this very last one. I want to walk through this one together because our hydrogens are separated on this side, but together on this side. So your atom inventory, we have Pb, O, H, and Cl. You'll notice I did not keep the polyatomic ion hydroxide together, and that's because it splits up on the other side. So if we look at our atom inventory, 1 lead, we have 2 oxygen here, 2 hydrogen, and another one for a total of 3 hydrogen and 1 chlorine. On our product side, we have 1 lead, 1 oxygen, 2 hydrogen, and 2 chlorine. We want to start with metals first. Our metal, lead, is already balanced. And then let's go non-metals. So we'll go to chlorine next. To balance chlorine, we need to take this 2 and 1 and make them equal. This 1 can turn into a 2 with a coefficient of 2 here. This now changes to 2. But it also changes our hydrogen. So now our hydrogen total on this side is 2 and 2, so it's 4. So this 3 turns into a 4. Next, we want to balance hydrogen because it goes metal, non-metal, hydrogen, oxygen. So our hydrogen is 2 here and 4 here. We can take this 2 and turn it into a 4 by multiplying it by 2. We change this now as 4. That also changes, though, our oxygen, of course, and our oxygen's now 2. But that works out perfectly because now 1 lead, 2 oxygens, 4 hydrogen, 2 chlorine. And let's just double check on our reaction as well. 1 lead, 1 lead. 2 oxygen, 2 oxygen. 2 and 4 hydrogen, 2 and 4 hydrogen, 2 chlorine, 2 chlorine. Okay, so you guys now know how to balance chemical reactions, the different parts of the chemical reaction, and then all of the vocabulary involved with that. That's it for chemical reaction notes.